In this video, we're going to be solving another everyday math question from past papers, and this question is from May-June 2020, paper 2, variant 1. Basically the year of the pandemic, the year the papers weren't held, basically. Okay, so let's get straight to it. It says Anton, I'm just going to call him Mr. A, invests $6,000 in an account for 5 years. The account has a compound interest rate of 2.5% per year. At the end of 5 years, he spends $4,200 of this money on a family holiday to Malaysia. How much money is left in the account? Okay, so this is not a straightforward, a regular compound interest question. Okay, the way to approach this question would be that you need to first find out the amount of money that he has in his account after 5 years, and then you need to find out how much money is left after he has spent $4,200 on a family holiday to Malaysia. Okay, so let's get straight to it. So since this is compound interest, the formula that we're going to be using is total is equals to the principal amount into 100 plus r upon 100 raised to the power of n, which represents the number of times interest has been added. So total is equal to the principal amount, which is 6,000, into 100 plus 2.5. So you can straight away turn this to 100 and 2.5 upon 100 raised to the power of 5. Okay, so I'm going to do this as it is in my calculator. So when I do that, 6,000 into bracket open fraction 102.5 over 100 bracket close raised to the power of 5. So I am looking at 6,788.449. So let's not round this off because this is not the final answer yet. So let's just make this correct to 2 decimal places. Now remember, from this amount, he is spending how many dollars? $4,200 on a family holiday. So that means he is now left with 2,000. So here's what I've done. Okay, I should mention this. So from this, I have deducted 4,200 because this is the amount that he has spent. All right, and bear in mind that this was the total amount, total after 5 years. So that means now he is left with 2,588.449. So that means 2,500.449. So 45, or you can even give your answer correct to the nearest dollar, although it doesn't say anywhere in this question, which means that we have a standard rule of rounding answers correct to 3 significant figures. But the acceptable range, even if you give your answer as 2,588 or 2,588, sorry, it will be accepted since it lies inside the acceptable range. Or you can round this off correct to 3 significant figures, which means that 2,590, since that's what the standard rule is. All right, now part B. Part B says Mr. A changes $800 into Malaysian ringgits for his trip. The exchange rate is $1 is to 3.16 Malaysian ringgits. He spends 2,250 Malaysian ringgits and then changes the remaining money back into dollars. The exchange rate on his return is $1 is equals to 3.27. So yeah, this makes sense. Whenever you go on a foreign holiday, obviously you need to have the local currency that is used in that particular country, because dollars are essentially going to be useless. And then when you're coming back, that currency is useless for you because they're not going to work in your home country. So you convert this back into the currency that you normally use. So what I need to do is I need to first find out that the $800 that he changes to Malaysian ringgits, how many Malaysian ringgits does he get for that? So $1 is equal to 3.16, right? MYR, I hope I'm pronouncing this correctly. So for 800, he's going to get X. So let's cross multiply. So 800 multiplied by 3.16 gives me 2,528 Malaysian ringgits, right? That's sorted out. Now, remember that he is going to spend 2,250 of this amount. So that means that the leftover amount, so minus 2,250, is equal to 278. So this right here is the remaining amount. Now this remaining amount, if is going to be useless, I mean this currency is going to be useless in the US. So what he needs to do is he needs to convert it back into dollars, and when he does that, we know what the exchange rate is. The exchange rate is that for $1 you get 3.27 Malaysian ringgits. And he has how many ringgits to exchange? 278. So X. So 278 divided by 3.27. Sorry, 3.27. I accidentally wrote 3.72. So he gets 85.0. But remember, if you read the question here, it says give your answer correct to the nearest dollar. So I'm looking at 85.01, which if I give correct to the nearest dollars is obviously going to be correct to the nearest dollar, sorry, is obviously going to be 85. Okay, now we turn to part C, which says again, Mr. A invests $1,500 in another account. The account has a compound interest of rate P% per year. At the end of 3 years, there is 1598.85. So that means this is the total amount. In the account, calculate P, give your answer correct to 2 decimal places. So again, we're going to use the same formula, same as the one we used in part A, but this time we know the total. So I'll immediately replace it with that. 1598.95 is equals to the principal amount, which is 1500, multiplied by 100 plus P upon 100 raised to the power of 3, since he's going to leave the money there for 3 years. In fact, since after leaving the money for 3 years, it turns into 1598.95. Okay, so this requires a lot of calculations. So the first thing I need to do is I need to take this 1500 on the left hand side, which means it's going to get divided by 1598.95 over 1500, and this is going to be equal to 100 plus P upon 100 raised to the power of 3. So after I've done 1598.95 over 1500, I need to take the cube root on both sides. And why exactly do I need to do that? Because I need to get rid of the cube. In order to get rid of the square, you take the square root. In order to get rid of the cube, you take the cube root on both sides. So I'm going to do that in my calculator just now. 1598.95 divided by 1500. Now I'm going to take the, wait, let me do that again. 1598.95 divided by 1500. So I'm looking at a certain value, which is 1.065 something. And then I'm going to take the cube root of this value. So shift cube root answer. So I'm looking at 1.0215 something something is equals to 100 plus P upon 100. So now I'm going to multiply this value by 100. So this becomes 102.15 is equals to 100 plus P. Now if you want the value of P, you need to subtract 100 from 102.15, which is exactly what I'm going to do now. And I finally have the value of P, which is equal to 2.15%, correct to 2 decimal places. So it's 2.152, which will remain 2.15. So there you go, part C is also done. And this question is worth how many marks? 3 plus 3 is 6, 6 plus 3 is 9. So 9 marks. So again, cannot emphasize enough on how important everyday math is for paper 2. So yeah, that's all for this video. I'll see you guys in the next one. Until then, take care.